Hey everyone, this is Daniel for Rock the Code, and in today's episode, my guest is Trisha Gee. She's a software engineer with more than 20 years of experience, a Java champion, and author of several books on Java and developer productivity. She makes frequent appearances at conferences, at keynotes, and on YouTube, and has held various roles in engineering, developer advocacy, training, and now managing an open source project. And the thing that I like most about Trisha is that she really deeply internally knows the developer mindset and audience and cares about them. And this conversation covers many things, including the death of Stack Overflow, how Trisha uses AI, the future of IDEs, burnout and how to recover from that, and the software job market, and a lot more. So please enjoy a wide-ranging conversation with Trisha Gee. Trisha, thank you so much for making the time. It's great to have you.
Thank you very much for inviting me.
So, out of all the places that we could start, I landed on Stack Overflow, which is very close to dead at this point. What do you think we can take away from this? What does that say about our natures as software developers?
Oh, you're going straight for the hard stuff, like no
Right.
soft technically with this. Okay. I have lots of opinions on this. The first thing is that this industry has always moved quite quickly and it's always moved from thing to thing to thing, right? And Stack Overflow it filled a really necessary gap back when it started, which I can't remember when it was now. It was like, 20 years ago or something. We used to search for answers on the internet and you didn't know the quality of the answers. A lot of them were behind paywalls or registrations, things like that. And probably a lot of listeners to this podcast don't even remember a time when that was a thing. Like back in those days, I would say there was less freely available help, information, open source. Like the internet was a fairly new thing. So obviously people weren't necessarily used to just putting code and examples and stuff out there. So Stack Overflow was amazing back then. And like it kind of took over pretty quickly from various other message forums and other places where you'd find information. So I guess I'm starting with that because like Stack Overflow itself was part of a kind of revolution in how developers learned. And it was also one of those things that there was a lot of grumpy old people saying, oh my God, you just copied and pasted that from Stack Overflow. You don't understand the programming concepts. You didn't really understand what you were doing. And all of that was sort of true. But the fact is, before Stack Overflow, knowledge wasn't democratized like that. It was just kind of you had to find it in books or find it on particular individual sites. And you couldn't just ask a stranger for help. And I really liked the way that it became a key part of the software industry where you could comfortably ask for help and also just freely provide help and not expect anything in return apart from little badges on your little profile, right? And I think that was overall a good thing for the industry. It probably was also very responsible for creating a lot of the content that trained LLMs, right? Because there's whole swathes of free, helpful information on Stack Overflow about how to fix particular errors or how to troubleshoot things. So it's sort of in some ways its success may have contributed to its downfall as well, the fact that this information is freely available. So now people are going to go to an LLM and say, how do you fix this thing? I do it a bunch. I did it today. I've got some weird error on a terminal, which I didn't understand. I put it into Claude and said, tell me what this is, because I don't understand what it is. And in the past, I probably would have gone to Google and Stack Overflow to find that. So LLMs have somewhat replaced that, especially if you're deep inside your code and you've got your Claude stuff like giving you context sensitive help, which is way more helpful than some random Stack Overflow answer. However, I also think we're somewhat turning a corner a little bit, and maybe I'm early in this, but I think we're already starting to see LLM generated content feeding LLMs. And we're starting to get this sort of cycle of like, how can you tell good quality answers or good quality material or good quality blog posts or content? Because so much rubbish being spewed out onto the internet by the machines. I'm wondering if it's time for a tiny course correct there in terms of we still need good quality answers, content, knowledge, materials in order to feed the machines with something helpful. So I'm wondering if there's a future for something like Stack Overflow, which might be somewhat different to what it is right now, but there's still a demand for real expertise to come up with genuine solutions to potentially novel problems. Like an LLM can't answer a novel problem or a problem that it doesn't know anything about because like it doesn't know anything about it. Whereas on Stack Overflow, you might find that one human being who has that weird knowledge from some system running from 300 years ago.
What does the downfall of Stack Overflow say about us as developers in the sense of, and I can contextualize this, um, and I can speak from my own experience as a teacher. So the way that I generally create my learning material is so that you can really compress your learning time, so that you don't learn good fundamentals and really great depth out of disparate blog posts and Stack Overflow answers and YouTube tutorials. But it seems that we are always looking for the easy answer. I mean, it used to be Stack Overflow, now it's Claude or ChatGPT or whatever, without necessarily taking the time to go through the really um, sometimes gruesome fundamentals and hitting your head against the wall until you really figure out what's behind the scenes, so that you can actually get going. But rather, we're looking for the quick fix. Um, to what degree do
Yeah.
you think this is true?
I think that, yes, it definitely is true. And I think there's a number of different reasons for it. One is we love ooh shiny and we love let's get going straight away. And
Hmm.
we're an impatient species as developers. But there's also external pressures on us too. So we often, what I see a lot of, I used to answer a lot of questions on Stack Overflow, on MongoDB, or on testing, or on Java. And so you get a sense from some of these questions that this is some poor, undertrained junior to mid-level developer just going, like I used to answer questions about class path, which is one of these fundamental things that if you went to university and studied Java from right from the beginning, which is what I did, I studied it at 1.1, and you do it right from the basics without an IDE, and you set it up on your computer, you know what a class path is, and you know what all the problems are. But I got the sense from a lot of people asking these questions is that they get flung onto a project somewhere, they get stuck onto an IDE, they haven't been provided with the right amount of training. They might come from a different programming language, or they might come straight out of university, and suddenly they're getting class path errors and they're like, I don't know what this is. But they clearly don't have any senior mentoring people sitting them down and saying, look, this is the system that we work on, this is the set of technologies we use, these are the kinds of errors you're going to see. Or even if they don't do that, they're not providing a nice safe place to ask questions like, what's this class path error, right? Or there's some lone wolf developers, I've seen this a bunch too, lone wolf developers who are trying to create something for some non-technical client, and they're trying to do everything and they're not experts on everything. So, these folks have a lot of external pressures to just get stuff done. And I came from a sort of traditional path of doing computer science, and I learned, programming when I was young, and I love programming. And I'm also somewhat, I'm a book reader, and I like to read things from beginning to end. So I like to do things properly, where properly is my definition of properly. And so I could get sucked into the temptation to think, well, these folks aren't really proper programmers. They're not learning the fundamentals. They're just making things worse by hacking stuff and getting stuff out there. However, over like 25 years of my career, what I've seen is like a lot of developers work in those environments, whether they're big companies just getting stuff done or small companies just getting stuff done. The key thing is a lot of them actually do deliver things which deliver business value, that make money, that get stuff done. Like some of these things do fail, but you don't always have to understand the bits and bytes in order to produce a product that is useful for customers, useful for the business. So I don't think we need to be too snobby about, oh no, you don't know what a class path is. Let me take you down to Java 101, when they're like, look, I just need to get this out the door, right? So I do think that we do tend to try and shortcut things. I do think as well we have a lot of external pressures on us trying to, we have to do things without being able to do the fundamentals. But I also think it's it's a nice luxury in our industry that we can piece together knowledge from some YouTube videos, Stack Overflow, stuff on Twitter, and have enough to actually do something helpful and useful for people. And I think that's something glorious. We don't have to go to medical school or law school and or learn 7 years of actual architecting, like physical building architecting. We can just get going right away. And I don't think we should be sneery about that. I think what we need to do is find the balance. And if I was building a team, I'd probably want some people with good, solid fundamentals, and I'd want some people who just like go, "Oh, shiny, let me see how this works," right? I think it's nice to have that diversity.
That's very cool. I mean, I love the way that you empathize with the need to get stuff done without necessarily having to grind your teeth until you understand how CPUs work in order to, I don't know, push a button somewhere. Um,
Right.
but I wanted to ask where you draw the line. I mean, to put this into a context, I see this conversation, and I mean, in the communities that I'm part of, the tension between the folks with the mindset that you were describing, that you were taught with, and to a large extent, this was my upbringing into computer science as well. I mean, the quote unquote proper way, like the very linear. You read books, you understand things really well. I mean, you deliver really powerful big projects before you are being onboarded into a real thing that delivers business value. But to a large extent, we've accelerated that to the degree that we don't really care about the code anymore, which may be the other extreme. So the question is, where is a good balance?
You know the answer is going to be it depends, right? So, for example, I was talking to a friend of mine who's a business analyst. She's worked a bunch with financial markets in the past, like with some really seriously technical people. But she's working in a really small startup where they can't afford developers, and they've tried to get developers, but they can't afford them, right? Now with agentic coding, etc., she has enough experience and background to be able to write prototypes, proof of concepts, examples that are helpful for her customers and her users. Um, and that's AI has been really helpful for her business. It helps her to expand more rapidly than she would normally have been able to. And then maybe with those proof of concepts, maybe she'll hand those over to a client and say, now get some real developers and go off and do something more solid and reliable and all the rest of it. So I think there's always space for doing something quick and dirty. I think I think it's nice that we have lowered the barrier to entry to that. But I think we need to recognize that we're doing something quick and dirty. So, for example, my friend, she knows she's not a developer. She knows the limitations of the stuff that she's producing. It's a proof of concept, and she'll be very clear to customers and clients that this is not something that you can put into production, and you need resilience and reliability and failover, like all the stuff that isn't there, security, all those things, right? You need to know what those boundaries are. Whereas I think if you take junior developers, I've seen this with consultancies over the last 25 years. This is not just a modern phenomenon. You know, some big consultancy will put a whole bunch of junior devs on some project and then just say, do it, because all they want to do is take the money out of it. And these juniors are like doing their best to get stuff out there, but they don't know what they don't know. They don't know which shortcuts they're taking. They don't know. I mean, you see it with it repeated in the story of AI. People like prototyping stuff and then finding they need security and they need, you know,
Their
that
database
kind
is
of
gone after 3 weeks in
ex
production.
exactly all the things that a seasoned engineer would know to do. But junior engineers have been doing that for years. The difference is that like uh, if you're doing it quick and dirty, you should understand you're doing it quick and dirty, right? And if I want to create a product or yeah, a product or an application that is good, my definition of good, I'm going to need to have developers who know what they're doing. Not all of them. Like, I just need a good, solid foundation of developers who've got the fundamentals, who are willing to coach and mentor the others. And the team needs to understand which things they care about and which things they don't care about. Because not every team cares about doing low latency, high throughput systems and minimizing garbage collection and minimizing network calls, because that you might need that when you're doing a financial exchange, but you don't necessarily need that if you're doing an Android app where most of the calls are going to the back end. You know, you don't need a low latency back end for that kind of thing. So, as with any architecture, it's all about the team architecture is the same as the physical architecture. Like, where are the trade-offs? Like, how many quick and dirty people do we need, and how can we help people deliver what we need, and how can we communicate what we expect from them? Like, because do need to be able to say to certain types of developers, no, don't do it that way. This is what we expect, and this is why we expect it.
Now, a lot of hard parts of software practice haven't really changed, really. I mean, reading unfamiliar code, knowing what to test, what to throw away, these things have stayed pretty much constant regardless of the tech and tools and processes. Can you walk us through what those, I mean, I would say hard parts actually look like day to day? And if there have been any changes to the skill of doing them in these days?
The thing I've been thinking about recently in this space, so there's lots of things that haven't changed, right? I could list loads of them, but like the mindset that I've found kind of helpful from a development team point of view is that regardless of how fast you can get Claude Code to churn out lines of code, what's still really important is, am I building the right thing? Are the requirements correct? Are the requirements correct, and am I meeting those requirements? So am I building the right thing, and am I building it right? So sort of somewhat downstream, like, how am I packaging it, deploying it? Is it going through continuous delivery? Is it being tested? Am I able to release it consistently? Is it bringing down production? So a lot of the AI stories are all around writing code, which was never the bottleneck in the first place, but let's not talk about that. The important point, and has always been the important point, is like, what are we building? Like, what are the requirements? Do we really understand what's going to add business value? Does the business understand what's going to add business value? And I feel like, and the other side, building it and pushing it and put it to production. And both of these, I think, are being somewhat ignored in the AI conversation. And I think that's really, really naive, because I feel like now that we can write more code and deliver more business value, I'm worried that the temptation is that more folks in, let's say it's a big organization with a big development team, I'm worried that the business will start to try and just like fling arbitrary requirements at the team and just be like, well, we don't really know what to build or how to build it. So now you can write code more quickly. Let's just do more and let's see what works. And because before it was kind of expensive to do new features or bug fixes or whatever, so we had to prioritize to make sure that we got the most out of it. And I'm a bit worried there's going to be somewhat of a backlash against that and be like, well, we should just experiment and chuck stuff out there. But being experimental is a very specific thing. Let's have a hypothesis. Let's like try to test if that hypothesis is correct, and let's circle around, let's implement it, test it, let's circle around and find out whether the hypothesis is correct or not. And if the hypothesis is incorrect, let's throw it away, start again. So being experimental is not just get Claude Code to write as many lines of code as possible and just stick stuff out there and see if the users still pay money, right? It's like, we have a hypothesis that by adding this feature to our application, we will increase user revenue by blah, or user retention or whatever. And then you put it out through the process and you have a look, did it work? Oh, no, it didn't work. Because one of the other things that's really important is I don't want to use the word refactoring because people kind of use that incorrectly, but like, you can comfortably build up what we call tech debt by continually writing more lines of code, right? And I think if the AI is writing more lines of code, it's going to, Kent Beck talks about this, the opportunity cost and cost of change. But if you put more lines of code in, it's just going to become more difficult to create more lines of code in the system. And so I think it's really important to measure whether the thing that we did had an impact, because we probably want to roll stuff back or delete things or prune the code base. So I think we should not fall into the temptation of let's just do more stuff because we can do more stuff. And also on the continuous delivery side, which is kind of what I was looking at for the last 3 years or so, if we've got more code, hopefully more tests, but possibly more naive tests, which take longer to run, then our continuous delivery pipeline is going to slow down. It's really going to start to creak under the pressure of all the code that Claude or whatever is writing. And if it's not, the places I've seen that the CD system is not creaking is because it's creaking under the process of code review, where Claude wrote like 500 lines of code and some poor human has to review that. And that's what's slowing us down. So the downstream stuff is slowing us down too. I won't talk about code review because I will rant about it forever. But the point is that if we can speed up writing the code, I think what it should show us is all the areas of our process that perhaps we hadn't quite got right in the first place. And we should be looking at improving the whole process, not just can we deliver more lines of code.
So I got multiple ideas out of that answer. One is the effective versus efficient kind of
Mm.
uh, dichotomy. I mean, effective means doing the right thing, and efficient means doing things the right way. I mean, or to the highest performance possible, or to the highest speed possible. And what's important is to be effective rather than efficient. And AIs have made us incredibly efficient and
Yeah.
multiples, maybe orders of magnitude more efficient. But it also incentivizes us to be less effective because we just push out features that we haven't really thought through whether we need them or not. That's
Yeah.
one thing. Then I got the scientific method approach. I mean, we hypothesize, we test, we see if it worked or not, and we put it out or take it down depending on the outcome. And then I heard some remnants from your talk about tests slowing
Mm.
you down. So we could go on many directions here, but I landed on this refactor. I just noticed a phrase that you were using. You said, correct me if I'm wrong. You said that people are using the refactor term incorrectly. What do you mean by
Yeah.
that?
So, well, firstly, I'm not going to define what it means to use it correctly because I think lots of people use it in different ways.
Mm-hmm.
Okay, and I don't want to use refactor to mean one thing and someone else is thinking about something else. One of the things I do see it's being used incorrectly for is refactoring as a way of addressing tech debt. There's also some people don't like the term tech debt, but let's use the word term tech debt because everyone knows there's applications where you have stuff you'd rather have done differently
Right.
and bits of the code that's a bit more difficult to change. So sometimes people use refactoring to mean addressing tech debt. You're like, well, no, that's not really like addressing tech debt is just another Jira ticket or another feature or bug, it's another card. But again, if you use the word refactoring, in that context, it could go on forever. Let's refactor the code base so that it's better. You're like, okay. Or what if we decided, the risk engine is particularly difficult to change, and so let's time box 2 days to change the bits of the code that are particularly hairy, right? Something like that. So I think it's much better to when you're talking about tech debt to kind of address it in terms of like what are the be outcome based. A lot of this stuff is all about being outcome based. What's the outcome we want to achieve? Well, we want that area of code to be easier to change, easier to understand. We want it to touch less files when we make changes, whatever it is, rather than use the word refactor, because refactor is like, oh, I'm just gonna mess around in the code base and make it prettier for some definition of prettier, right? Another thing that people use refactor for, which is kind of similar, is rewrite. I'm going to refactor it, meaning rewrite. But if you are rewriting it, refactoring it in terms of the rewrite, and you don't have sort of system level tests or acceptance level tests, end-to-end tests, that's not really a refactor. That's a rewrite, and a refactoring should be something you can safely do. So you're going to rename a method, or you're going to move stuff around, or you're going to break one method into two methods, or whatever. It could be bigger than that. It could be architectural, but like IntelliJ IDEA specifically should be able to do a refactor fairly deterministically and know that you haven't broken anything serious, right? But if you're going to start changing the architecture of your system to make it prettier, then and you don't have the tests to back you up, then you're not doing a refactor, you're doing a high risk operation, and you don't know what your end goal is, or how you've met the goals that you want to achieve. So I think a lot of people use refactor to mean I'm going to go back and tidy this up to the way I want it to be later. When I think it should be more like the red green refactor loop of write my tests, write my code. And I know this is old fashioned because it's as if I was writing code instead of Claude writing the code, right? But like the refactor should be in the context of this feature that I'm working on. now it's working and the tests are working. Now I'm going to refactor it. I'm going to make some small changes so that maybe I'm going to move some code around, but everything still works the same way. And the important thing is after refactoring, the system should still work the same way. And refactoring is not going to change behavior, but sometimes you see that that's not what refactoring is about.
Yeah, for sure. You touched upon the IDEs, so I would like to talk about that next because now with AIs, we have a whole new generation of development tools that are being, I would say, experimented on. I won't even call them full products yet. Things like anti gravity, even air from JetBrains, um, that have agents baked into them. How relevant is a proper IDE anymore? A proper meaning, let's say,
Like an
classical
IntelliJ
IDE.
idea. Yeah.
How relevant is that anymore? What features have you seen that would be very helpful in an agentic focused development environment? And how do you think about this direction in general?
I ask myself this question frequently. I mean, I released a book about IntelliJ IDEA, what, 2 years ago, and almost immediately out comes AI. I'm like, seriously, I've been using IntelliJ for 15 years, been meaning to write this book for 15 years. And as soon as I do, suddenly IDEs aren't relevant anymore. You're like, oh my God. Um, it's I don't think we know the answer to this question yet. We're still in this, as you say, sort of somewhat experimental time. And I don't just mean experimental in terms of new tools. I mean, like, as a developer, I'm kind of, I haven't really figured out my best flow yet. And the tools don't necessarily support all the things I want to do. Um, and for me specifically, as a Java developer who's used IntelliJ for like 15, 20 years or whatever it is, I'm going to have certain expectations from my tooling, from deterministic refactoring tools, from keyboard shortcuts, from navigation, from working that way for 20 years, which is going to be different to some of the up and coming developers. Like, I'm going to be fast in IntelliJ IDEA because I've been using it for so long and I know what I want to do in it. It may not be relevant for me to inflict that knowledge on a junior dev right now because it may not be so helpful for the way that they work. But for me, I might be able to combine that tool with agentic coding or whatever, or some other IDEs as well, in order while we have these gaps in the tooling and the processes. So I definitely don't want to say the IDE is dead because that would make me very sad. It definitely has to evolve. There's things which I haven't written as much code for the last X many years, really, because I've been doing leadership stuff and strategic stuff and developer advocacy stuff. But I still use IntelliJ for if I'm trying to get my head around a new code base, I'll still use the navigation tools. I want it to tell me like what calls what where, and I'll use it for deterministic refactoring. I'm using Claude or whatever to tell me what does this project do? Where are the entry points? What are I even ask it like how would you improve this project or things like that. But the IDE will allow me to step through, navigate it, run the tests. It will allow me to um, see diffs. I use the IDE for navigating the Git history as well. I know not everyone's going to use it in a visual way, but I like looking at the Git history in the IDE because I want to be able to see like who did what when, what are the branches like, and that gives me some hints on how a project is working. But I guess I'm not the same as most developers because what I'm often doing is picking up a new project, taking a look at it, seeing what's there, rather than embedded in something where I'm writing lots of code for a known project. I was on the IntelliJ IDEA documentary, which was recorded, I think, last October, which is not that long ago. And I said back then, I think that what's really important is good diff tools in the IDEs. And I think even now I've slightly changed my mind on that because like I don't really want to be doing line by line diffing of what my agent did versus what the code looked like, especially as I might not even really have understood the code before the agent started changing it. So I might need something different to just line by line diffs.
How
What I
so?
would like to see, I would like to see the deterministic stuff inside the IDE, like the refactoring tools used by the agents. I don't want Claude to do a find replace by name on my method names. I want it to call the IntelliJ deterministic refactoring. That I would love to see more bi-directional communication.
Right. So rather tool calling rather than just string slash text file manipulation.
Exactly, yeah.
What do you think is a piece of interface from a classical IDE that should die?
Oh, I like that one. What should die? I don't I don't know. I don't feel strongly about that. I can tell you what was annoying me about IntelliJ last year. And yeah, and maybe things have moved on, but as we moved from the classic IDE with a bit of code completion, and then we ended up with like the full line code completion. I freaking hate full line code completion. It's never what I want it to be, and it's just a massive distraction. One of the things I thought IntelliJ always did well is that they give you context sensitive stuff wherever you are. So like when you're debugging and it gives you like those comment style things which shows you all the values of the variables as you're going, and everything is always exactly where you want it, exactly where you're looking at it. Full line code completion, which obviously wasn't just IntelliJ, it was like all the IDEs were doing it. I felt like that was the opposite. I felt like that was just like shoving stuff in your face and saying, pick me, pick me. And I'm like, could you not just slow down? I need to think about what I want to do. I don't want you to be, and it's the same thing in Google Docs when it's trying to predict my next lines. I'm like, could you leave me alone? I'm trying to think, that I would like to get rid of that in all applications because I feel like it's very rare when I'm in the middle of typing code or writing text that I'm I'm not going to know what my next word is, right? I don't need you to tell me the wrong thing. And if you're telling me the right thing, I've already typed it by the time I've recognized what you're doing.
Yeah, and the hit rate is probably going to be very low in the sense that the completion suggestion is not going to be exactly what you had in mind, so that you can just hit tab.
Yeah, every time you hit tab and then go back, 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 that drives me insane because that's the opposite of flow. That's the opposite of everything I've learned from being inside the IDE. I did learn that with IntelliJ, you can sort of tab through the individual bits of the completion, but the keyboard shortcut is kind of weird. I have to look it up every time, and I still feel, and this might be a me thing because of the way my muscle memory works, but I'm like, I would just much rather just individually select the methods and the names that I want as I go. I don't want you to put something in my face because now I have to think about it, and I don't want to have to think about that.
Yeah, it's kind of hijacking your attention.
Yeah.
How do you teach people to read code better? I mean,
Yeah.
it seems to me that reading code is it has always been a huge part of the proper software development cycle, and now with AI, reading code is a much larger chunk of that because we're writing code less. I mean, uh, in the sense of actually producing it with our own two hands. How do you teach people?
I've got to talk about reading code. Because it came off the back of me talking about code reviews, and I realized that developers are, I don't want to say bad at reading code. We're not encouraged to read code. We're not taught how to read code. We're taught how to write it. You go to university, you do Hello World, and you run stuff, and you don't really read the code. So I've thought for a long time that we should have focused more on the skill of reading code. Um, it is difficult though, because I mean, I love reading books and I love writing code. I do not love reading code. I absolutely hate reading code, especially if it's someone else's code. I'm just like, what is this? What have you done? Why are you doing it this way? And one of the challenges, of course, is the code is non-linear. It's not a story. You're not going to read it this way.
Well, you're going to
IDEs
jump and show.
help.
Yeah.
Exactly. IDEs help because you can kind of go in and you're going to go into this loop and you dig into this and you can jump over here and you can see what caused me. But like our poor human brains just aren't designed to think in this way of navigating through all these different classes or lines of code. So, which does argue for practicing it more. And I think what's even worse, and this is where my rant came from, the code review, the style of code review where you get faced with, I don't know, let's say even 10 files, which is a small amount, 10 files, a series of diffs, and you linearly look at the diffs side by side, and this is file A side by side, and this is file B side by side, and you go through it linearly. How is that meaningful in any way, shape, or form? Like you have no sense for the control flow, the data flow, the architecture, the hierarchies. Like there's so many different angles to look at code and look at working applications, and not one of them is a side-by-side diff of two different files. Like
Especially
that's
if it
not
touches code that is not part of the diff.
right, right, exactly. Exactly, because like you'll see this diff here and like, and then especially if there's magic code as well. So this diff changes some name somewhere and a property name or something. And then you've got to think, okay, where is that property used? Um, yeah, it's hard to read code. It's not very exciting to read code. It's particularly hard and you have to get into someone else's mind as well, because you're like, why did you structure it this way? And why are your methods so long? And why did you call it this thing? And in my talk about code review, about reading code, I talk about how judgy we are because we have a tendency to be like,
Oh, for
what
sure.
was this person thinking? And then you're like, oh, it was me. Oh, I was an idiot. What was I doing? You know,
How does that speak to the joy of writing code now with AI? I mean, there are both sides of the conversation. Some people say that it's now more fun to write code because you can
Mhm.
produce tangible things much faster. The other side of the conversation is that it's less joyful to do software because of what you're just describing. I hate reading code, especially if it's other people's code, especially if it's 10,000 lines of other people's code
Right.
to be reviewed yesterday. Where do you sit on that?
A lot of the people I'm speaking to who are enjoying the AI revolution are people like me who don't get much of a chance to code these days. So it's lovely for us because we're like, oh my God, I can actually finally do that thing I wanted to do. I rewrote my website, it's a WordPress site. I've been meaning to do it for about 6 years and I just got Claude to do it. Oh, nice, great, but that's not mission critical. And it's something that can be done. I did it in like a week. I feel like it should have taken less time, but whatever. But that's a very different experience to I'm working on a legacy system. Um, I might even have difficulty plugging in the agents to the bits that I really need the agents in, right? Like if you've got some really hairy, nasty old code that needs explaining, but it's on some, I don't know, some legacy system or it's behind a file. I don't know. I can just imagine these enormously old systems where like what you're doing is a lot of stuff around the edges and you can't really get any visibility over what's going on. And now you've got agents doing stuff for you, and you never really understood what you're doing in the first place. And now the agents are writing more code that you don't really understand. You know that it's at risk of breaking. You know there's a risk of something going horribly wrong, probably because you don't have good test coverage, you don't have an end-to-end test, you don't have a proper continuous delivery pipeline. That's why they rely on like code reviews and humans looking at stuff. And I can imagine that being enormously stressful. Whereas before, if you have to write 4 or 5 lines of code to make a change and it takes a week to get through the whole process, then that's kind of fairly low risk. But now you've got agents going away writing lots of code that you don't know what the risk is, and you're trying to understand it, then that's just got to be miserable, I would have thought.
How do we fix it? I mean, this is a road to burnout, and you've been through
Yes.
it, and you've spoken about it, you've written about it.
Well, I mean, the solution is easy. The solution is both easy and hard. The solution is easy, which is that we should be doing software engineering the proper way. We should have automated testing at multiple levels, unit level, end-to-end level, so that, people don't like unit tests because they say they're too brittle because you can't refactor stuff. And I'm like, yeah, but that's the point. Like if you want both. You want end-to-end tests so that if you're going to do some rewriting or refactoring or moving stuff around, you see that the business logic remains the same, but you also need the unit tests because you need to be able to run tests quickly and make sure that you haven't broken anything like really critical. So you need good test coverage. You need it at various different levels. You need to be running it all the time. You need to be continuously integrating, not having long-lived branches which are going off doing who knows what and then having merge problems later on down the line. You need to have automated release processes. You need to be able to run things locally on your laptop so that you can reproduce problems, debug things easily. You want your test suite not to take an hour and a half to run. You want to be able to do it in minutes so you have a good idea of like whether you broke anything. That's all just mostly from the automation and continuous delivery side of stuff. You also need to have a clear idea, like we said, like what are the requirements? What are we doing? What are we building? How are we building it? Who's responsible for what? Who does the code reviews? Who decides when it's signed off? What are we looking for when we review code? We just need good software engineering discipline. And the DORA reports show this. The folks that have got a culture of learning, that embrace change, that have work iteratively, that have fast feedback loops, that do continuous delivery, they are operating more quickly, more effectively. We talk about effective versus efficient, more effectively with AI because they were already doing the good engineering practices. The folks that had bottlenecks on their code review process, that didn't really have proper continuous delivery, that didn't have a culture of learning to pick up new stuff. These folks are really struggling because where they had problems before, they have 10x problems because they've got 10x more code. So the solution is known. I won't say it's easy. The solution is known. People have been writing about it for years. I've got all these books here. Like what I've got, yeah, continuous delivery book, modern software engineering. They're both by Dave Farley. Refactoring book, Tidy First. Kent's Tidy First book is really, really good. There's a whole bunch of stuff. XP, Agile, like all those things, not XP and Agile the way people have been doing it, the real way. All of those things are all kind of invented to allow us to do software engineering. And what's happened and what I've seen, and I've seen this in Silicon Valley companies that make a lot of money, is that they've been skipping a lot of that because they could just get away with it because they throw money at the problem and throw engineers at the problem. And now I think that the pressure that we get from putting engineers and agents and lots of unknowns at the problem is that everything's going to start crumbling if we don't put in place the engineering practices that we've known about for 30 odd years, if not more.
This seems to be a solution at the organizational level.
Mhm.
At the individual level, how does the solution look like to avoid this sort of burnout? I mean, the
Yeah.
threads that I read on Hacker News is the senior level developers are up to their neck in code reviews. They're
Mm.
tired. They've had enough at many levels. How do you think about that?
I think it's a very unpopular opinion and it's slow down. It's just like if your engineers are burning out, it's not working. Using agents to write more code to go faster is not working because you're going faster and you're burning out your people. If they could have gone faster before, they would have gone faster before. So slow down. And not just slow down as in try and deliver less, but slow down as in take the time to well, firstly, the thing that causes burnout, there's two things that really cause burnout in my experience. One is running at 100%, which is why I say slow down. So I think it was Holly Cummins said that in one of the talks that I did, like most systems should be running at like 80% capacity because if things go wrong, you have that buffer, right? And what we're seeing is that I think developers have been running at about 100% or 90% capacity already before AI. But with AI and with agentic coding, with lots more code, lots more things, lots more pressure to deliver, especially with layoffs and unsafe working environments, engineers now working at 100% capacity, which means that as soon as something goes wrong, as soon as like whether it's personal or professional or team or technology, you have no buffer to deal with that. And that's one thing that causes burnout. And another thing that causes burnout is doing the things that aren't the things that you love. Now, every job has stuff in that you don't love,
I mean,
right?
you
But
can
like
burn out with just doing things that you like. I mean, I know from
you can.
person. Yeah.
You can, and my first burnout was I did a lot of things that I liked, but that was definitely the 100% capacity problem for me. My second burnout was like doing stuff I was good at and I was effective at and even efficient at, but they're not things that brought me joy. And not everything has to bring you joy, but like if you're, a lot of us got into development because we like code, we like delivering, we like seeing the test go green, like whatever it is, like we just like hacking on stuff in whatever shape or form that takes it for us. But if now instead of writing code, we're reviewing code, like even if we're running at 60% capacity, it's just like we're not getting refilled with any of the things which help renew our battery. It's just draining our battery. And that's one of the other classic things that causes burnout. So if we're spending a lot of time doing things that aren't aligned with our values, aren't aligned with who we are, that causes burnout. So in order to address the 100% capacity, like teams need to be doing less. But in order to address the you're doing a lot of crap that you don't want to be doing, from an individual point of view, and the problem is the industry as it is right now, it's so difficult to just get a new job these days. So that's not necessarily an option, or if it is an option, do take a look. Because step one is step back and have a look at your job and go, are you loving it? You don't have to love it, but is it all crap that you don't enjoy? Or is there a balance? Is there a way that maybe you can pick up some more stuff that you enjoy? Like one of the things that I'm going to be doing in my new job is they're going to be doing an AI hackathon next week. And I'm really looking forward to that because I'm going to use the AI hackathon to try and one of my jobs is going to be doing documentation, which I know most people would freaking hate, but I really like documentation because I like to be able to write down how things work. And I'm really looking forward to using AI to dig through the documentation, give me some suggestions on what needs to be documented, maybe even some structural stuff, maybe even write some code to help me create a better platform for the documentation. I don't know what it is, but I'm really looking forward to that, right? And so that's the sort of thing that we want to be able to find the things that we can maybe spend a bit more time in and investing in. To help renew our sense from the burnout. I think burnout is really it's a real problem at the moment because of AI, but also because of the culture of fear, I think that we have in the industry these days, because they could just lay you off at any minute and it's going to be really hard to find a new job. So you just sort of have to do what you're told. It's much more difficult to say, hey, I'm not loving doing all these code reviews. What about if I just tried to address the problems with our continuous delivery pipeline instead? Because your manager might go, we don't need that, and you don't love doing this, so bye. Right? It's much more difficult for us to affect the change that we need these days. But I think perhaps some small changes like can we pivot our jobs into or pick up some tasks which make us feel good and maybe if not drop then maybe optimize some of the tasks which we're not loving.
This ties into uh, other phenomena that are happening in the industry because of the AI, and another kind of worry about the job market that is the worry that the AI is eating the junior level tasks and
Mm-hmm.
the the very sharp decline in junior level positions. How do you see people uh, becoming senior? I mean, how do we train people to build the judgment that makes a senior engineer?
I think, well, firstly, I want to address the thing about the declining number of junior jobs. Maybe I'm being super optimistic, but I think that this is a phase and it's part of the cycle. And I think that junior jobs will come back because I think people will go, oh, right. Well, firstly, I am seeing more seniors just retire now because they're like, no, I'm out. Like, I've earned enough and I don't want to live in fear and I don't want to learn a new technology. So that's going to help perhaps draw the pipeline up a little bit. Um, and secondly, I'm hearing stories from folks who are hiring juniors going, wow, juniors are great with AI because they have no preconceptions. Yes, you have to help mentor them as well. You can't just leave them alone with it, but they can educate themselves on the AI. They can get AI to help them like learn about solid or object oriented versus functional. That the AI can actually help you with that stuff. It's not just a stupid bot that writes code for you, right? So the organizations which are still hiring juniors are having a lot of success hiring juniors. And I think we'll find they'll be able to compete more effectively. And some other organizations are going to start going, oh, right, okay, well, maybe we should start hiring juniors because they're quite cheap. I'm also seeing organizations that where their AI spend is higher than their developer spend. And they're starting to think, well, maybe we don't need to spend so much on AI. Maybe we could invest in humans. So I hope optimistically that this is somewhat of a part of the cycle, maybe a bit of a blip, and we will start hiring juniors. We've never really been able to hire as many developers in the industry as we needed anyway. So I don't have a huge fear for the role of developer going forward. I think we're trying to figure out what it looks like now. But software is eating the world. We're always going to need people who can create software however that looks going forward. And then the second part was, it's about the path to senior. I mean, I feel very strongly that it's really important to train and mentor developers. I When I worked at LMAX and we did pair programming, I learnt more in 6 months there than I had in the previous 10 years as a senior developer or as a Java developer. Because before, and this cycles back to what we were talking about, before I was learning off Stack Overflow, learning off little bits and pieces here, I was reading books, but not really seeing how that knowledge applied in the real world. I had a lot of like knowledge, but I didn't really know how to always apply it in the right situation. And when I was pairing with people like Martin Thompson and Dave Farley and Steve Smith and Amir and like all these folks at LMAX, and they just kind of, and they're talking through their thought processes as they're trying to decide what to call a variable. I'm like, oh, right. Now I'm learning what to pay attention to and what not to pay attention to. So the thing about becoming a senior developer is it's not about learning more APIs or learning more languages. It never was. It was always about understanding the trade-offs you're making when you make a decision. So I was always paralyzed when I was writing code because I'm like, oh, I can see at least 5 different ways of implementing this solution. And I'd go down one path and I'd be like, oh, no, but that's going to make it hard to do this. And I'd back that out and I'd go down another path and I'd be like, oh, no, but now I can't do this. And I was always like torn between all the different solutions. But working with more senior folks and even with more junior folks allowed me to learn the questions to ask myself around, okay, what is good about this solution? What is bad about this solution? Where are the trade-offs? Maybe there's a third way, which is a better solution. And so that's the sort of thing we need to be teaching the junior devs, not like how to work with Claude or how to use the IDE, although those things come as well, especially if you're pairing. But it's about, okay, if you have this solution, whether you wrote it yourself or whether Claude gave it to you, what does it mean for the code? What does it mean for the user? What does it mean for flexibility in the future? Kent Beck talks a lot about optionality, which I found really interesting because he talks about like if we take this decision, this design decision now, how does that impact our ability to make change to the system in the future? And in order to, an effective system is a system that's easy to change. So what you want to do is keep your optionality open so that it's easier to change in the future. And something that some of the agents are bad at, because some of the agents just write crappy code occasionally, is not, they don't think about optionality, they think about solutions. And this is code that fixes this, and this is code that fixes this, and this is code that does that. And they're not thinking, yeah, but when you put those three things together, suddenly we can't do this anymore because of the way that the design has evolved. And that's what we need to be coaching our developers. And that's what you need the human developers for, so that you can spot that and go, oh, no, we don't want to do that.
How does good mentoring look like? And you can also frame it from the side of the junior. How does a good junior or a good mentee look like?
I can answer that more easily. A good junior asks a lot of questions. And I guess the flip side of it, a good mentor or a good team culture, because it doesn't have to be an individual, a good team culture is where it's safe to ask stupid questions. One of my things that I've always tried to do, provided I felt safe enough, is I would always ask stupid questions in the team. So I would set the tone of anyone can ask stupid questions. That's the thing that I do. So a good junior should be asking lots of questions, even stupid questions. A good team or a good mentor is going to make it safe to ask those questions. A good mentor is, I don't know. I mean, I've had, when I worked at Ford and I was a junior as a graduate, I had an official mentor, and he was from the business side. He wasn't, I mean, he worked in the IT organization, but he was on the business side, not technical. Um, and he was an older guy. He was of Indian descent, and he had like a wife and kids. And I was like this, little white girl. I'm like 21 years old, and so like we were very different types of people. And at first, and he wasn't technical, and I was very, very obsessed with I need to get good at the technology. This is what I want to do. And I was like, why am I paired with this guy? And I learned so much from him because he had all that knowledge and experience, which is totally different to mine. It's absolutely brilliant. One of the things he told me is that, particularly at Ford, he was talking about like, if you want to get ahead on the management track, if you want to be promoted, then you need to be willing to do the stuff that no one else wants to do, which might mean relocating to a plant that no one wants to work at, or taking on responsibilities that are unpleasant. And that was interesting to me. Later on, I actually used the relocation thing. I mean, I live in Spain now, so relocating was something I never really had on my agenda, but talking to him, and he's like, you're just going to learn more, you're going to expand your horizons, it will do interesting things to your career if you're geographically open to new experiences. Um, so sometimes it's really helpful if a mentor is like not from the same background or experience as you are. It depends what you want out of it, really. Um, but I think the main thing is just you need to feel safe. It needs to be a warm, safe environment.
What was it about the training that you did that you said compressed more internalized learning in 6 months than the previous 10 years of programming? What was it about that training?
So that's just it's pair programming. And like if you watch Dave Farley's YouTube channel, he goes on and on and on about pair programming, and his watchers are fed up with it because they're like, I don't want to pair, pairing is stupid. So I try not to talk too much about pairing because I know loads of people don't like it. And also I work remotely, so I can't really pair with people anymore. But literally sitting down next to someone all day, every day, a different person every day, pairing on an individual product, a project or individual feature. Um, I just learned so much because there's only 12 of us in the team, so it wasn't a huge team. It was a mix of people who were more junior than me, a bunch of folks. I was sort of mid-level, bunch of folks mid-level, and then some really senior folks. But we all paired with each other, and I just learned loads of different stuff. So the folks who'd been at LMAX for a while, they taught me a lot about the architecture and the design decisions and why we're going to make the changes here. People like Dave, he taught me about TDD, acceptance test driven development, and continuous delivery. We had a guy called Darren who was like really hardcore, like he's your typical programmer, like really good at the stuff that he's good at. He was always felt very uncomfortable pairing, but he did it anyway because he was like he knew it was really important to sort of share different ideas, and he used the VI key bindings in IntelliJ, no, the Emacs key bindings in IntelliJ IDEA, and I was like, oh God. But that was good to see a totally different way of working as well. So, and the juniors, and we had a couple of juniors, and pairing with them was great because they would just ask these really great questions like, why are you doing it this way? So, like we were using Spring. So a lot of the stuff was new to me, but Spring wasn't new to me. So I was like, we're going to do this, we're going to do that, we're going to do the other. And the junior was like, why are you doing it that way? And I was like, well, because that's what you do. I thought, oh, well, if my answer is if that's just because that's what you do, I need to think a bit more carefully about why am I doing it that way and what are we trying to achieve? So the juniors taught me to step back and not just do things by cargo cultism, by rote, by like just because we've always done it this way, but to stop and think about what we're trying to achieve. So I learned a lot of that. And also on top of that, everyone learned all the keyboard shortcuts for IntelliJ IDEA. Just because we all had our own little hacks and our own little ways of being effective. When I joined that team, like I didn't know anything about IDEs. I've been using one for like 5 years, but like not effectively at all. But everyone I paired with had their own set of skills. And a few years after that, I was working for JetBrains teaching people how to use the IDE because I learned so much pairing with those folks. And I'm like, look, this was like a mind-blowing experience. The only way I can try and do it is share a similar experience by like doing webinars and screencasts and talking at conferences and showing people, hey, this is how you do cool stuff with the IDE. The pair programming just left a big impression on me.
That's very cool. I wanted to ask, to what degree do you think such an experience is reproducible or compressible? And I'm asking this as a learning materials creator because a good chunk of my platform has been to compress learning time and to compress experience into very distilled examples that prove a point very quickly. To what degree do you think this internalized thing is reproducible?
I I think to some extent, yeah, I love this question because when I'm doing developer advocacy, I have like, especially if I'm giving a conference talk, I've got like 50 minutes to try and get an idea across. Or usually I'm trying to get 67 ideas across, right?
Mm.
And I want people to go away with that kind of compressed knowledge. So I really love this question. But I think the stuff that I learned while I was pairing in particular was all about repetition. So I'm not sure how much of that you can compress. I mean, in many ways, the 6 months was already compressed learning because, and I spent 4 years at LMAX, but it was the first 6 months where I just really like, I came in as sort of fairly standard mid-level, and by 6 months in, I would consider myself a fairly senior developer who knew a lot of the systems. And I think most people wouldn't be able to get up to speed in 6 months without the pairing. So I think that was as compressed as it could be. But I think also a lot of it is repetition, doing the same things all the time, and constantly reinforcing the same messages. Let's write our tests first. Let's do small commits. Let's commit to main. Let's make sure that let's. We used to have a process where so every ticket that we worked on was 2 to 3 days worth of work, and you always have to have what we called a BA hug. Go and talk to the business analysts and the testers beforehand, get their input on what it should be, how you test it. Go away for a couple of days. We would rotate pairs on it as well, so you'd always get like at least two other people's input on it, and then sign it off and give it to the testers. So doing the same things again and again was good because it kind of enforced what is the process, what does good look like, what do we accept, what do we not accept. And also like working on all these different things, you would know after a while, every time you see the word risk, these are the classes you're looking at. And every time you see, I don't know, gateway, you're going to look over here. So a lot of what we learned was repetition and being encouraged to do the same things again and again.
What does developer advocacy look like in the current environment? Are you still doing it?
Oh, yeah. I like that question. I was struggling a little bit with my identity. So firstly, my last year at Gradle, I wasn't really doing developer advocacy. I was doing more sort of like uh, DevRel and marketing strategy, which is kind of cool because I was sort of doing strategy and leadership instead of necessarily writing new talks and stuff. And then when I left Gradle, I was left with a little bit of a crisis of identity of what does DevRel look like in the current day and age, especially because my DevRel stuff was very tied to Java the language and IntelliJ IDEA. And like, who wants to learn about Java the language and IntelliJ IDEA when they just ask Claude Code to do it for them, right? So things are definitely the topics that we need to talk about and educate developers on have pivoted somewhat. My last talk that I gave at Devox UK, which isn't on the YouTube channel, I'm going to have to ask them why it's not there, is about, it's called Shiny New Tools Won't Fix Your Problem. Obviously, a slight dig at AI, but it's about like how the fundamentals, all the stuff we've just talked about, the fundamentals don't really change. So, as a developer advocate, what I want to do is tell people, remind people about what software engineering looks like, what Fred Brooks talked about when he was talking about the Mythical Man Month, and like what's the difference between the stuff in the refactoring book and Kent Beck's Tidy First book, and like I kind of want to just remind people about some of these things and why they're still applicable in this day and age. So I think that's kind of my journey in terms of the DevRel stuff. I kind of have gone I've got two things I want to talk about. One is the fundamentals that don't change, and the other is like I really love having these conversations about what does AI look like? What does it do? What's it good at? What's it bad at? Even though I'm not working on an engineering team at the moment and I don't have much first-hand experience. But I think an experienced engineer, and particularly an experienced developer advocate, should be able to look at a set of new tools like the AI tools and go, right, where does this fit in our industry? Where does it fit in the development process? What does it feel like for a developer to use? What are the pain points? Like, even if you're not doing it yourself necessarily, um, a developer advocate should be able. One of the things I've been thinking about is like a lot of my developer advocacy has been around developer tools. So like we should be able to look at those tools and go, okay, there's a whole new set of tools that solve new problems, but cause new problems. And what does that feel like? And how can I help developers with that? Especially given the background in the fundamentals. Like, okay, so maybe you're suffering with long release times. Perhaps you should go and read the continuous delivery book because that's literally what that was for, and help sort of close the loop on what is the new and exciting stuff and what's the classical stuff that we were sort of talking about a bit before, like what's the classical education foundation stuff that has always been there to fix some of these new problems that aren't new at all.
You've written and you've spoken quite a lot about the fact that staying relevant is obviously even more important now. How do you try to stay relevant in your own career?
Hmm. Well, mostly most of this last 6 months, I've been running around like a headless chicken going, oh my God, I need to learn about AI. Um, the staying relevant topic is driven by a lot of fear, I think. I certainly see it in definitely, I've seen it a lot in juniors, but I see it in seniors, especially now with AI. Like we have a lot of fear that we'll become irrelevant or difficult to hire. I see it a lot in women. If we think we're going to go off and have a baby, and in 4 months' time, our technical skills have rotted and no one's going to want to hire us, right? There's a lot of fear around staying relevant. And I definitely felt that for myself when I left Gradle. I'm like, well, I'm an IntelliJ and Java person. Like, what skills do I have that are relevant? How do I get up to speed on AI? I was invited to the Future of Software Engineering Summit. There's one going on now in Europe, but I was invited to the one in the US at the start of the year. I think it was March. And I'm like, I have nothing to offer to this summit because I haven't used AI enough. Um, so, firstly, I want to address the fear. A lot of our desire to stay relevant is based on fear, I think, rather than there are other types of people who love to chase the shiny. They're like, oh, look, AI is shiny. I want to do that. So some people are like, let's go off and learn new stuff because it's shiny. But I'm less worried about those folks because they'll always be able to stay relevant because they'll always be finding new fun stuff to be learning about. But folks who are worried about staying relevant, it's usually because they have a fear that they're not relevant anymore. So the fear is real. The reason to be afraid might not be real, but the fear is real, right? And it's particularly real and particularly worrying when jobs are going away, when AI is also changing the recruitment market and getting your CV. Oh, I saw an advert the other day for 10 years experience in Claude code. You're like, I'm sorry, what? Right? So these are sort of challenges that we have to kind of come across. Um, but I think in order to stay relevant, it's impossible to know everything all the time. It's impossible to have tried all the agentic coding frameworks. It's like, don't tell anyone, but I still don't know what Kubernetes is supposed to do. Like, I don't know. I'm barely up to speed on Docker. Cloud computing is not something I've really I haven't had to do infrastructure, DevOps, releasing apps since cloud came in. So I don't worry about that kind of thing. But like sometimes I worry that I don't know any of that space, but you can't learn all of it. You can't know the cloud and the tooling and the languages and stuff. So the first thing is you can't know everything, and that's fine. It's impossible. Job specs will tell you need to know everything, but that's absolute nonsense. Um, and then secondly, that releases you to look at the things which are interesting to you and start experimenting with those in order to retain your relevance, if you like. So like I said, the first thing I did after I left Gradle is rewrite my website with Claude because I'm like, oh, I really wanted to understand how Claude works and I really want my website to be updated. I don't want to learn WordPress, so this seems like a good way to actually get something done. And it was good, and I'm kind of sad that that all finished because I wanted another project. But like find little projects to kind of learn and grow and experiment with. And also the other thing to understand is that sometimes you'll play with the technology and you'll be like, oh, I'm not really getting on with it, or it's difficult, or it's not gelling for me, or I understand it, I just don't care. And that's fine too. It's really important to know that about yourself because imagine if you got a job using that technology and you'd be like, oh my God, I just really don't care about whatever it is. So it's good to try stuff out so you can see what you like and what you don't like.
How was the rebuilding of your site with Claude? Can you walk us through that process in a little bit more detail?
Yeah, I really wish I'd blogged about it, but I kind of did it. I was moving house at the time, so I kind of did it and then forgot to blog about it. Um, what did I do? And this is the first time I'd used Claude because I've been using ChatGPT because a lot of what I was doing was kind of like business strategy content stuff, which I found ChatGPT quite good at. Um, but I said to Claude, uh, oh, well, I asked it first. I was like, look, I want to update my website. It's in WordPress. I chose WordPress on purpose because had wanted to get a designer to reskin the thing well, I've had many websites. I had an old website. It was running, that one was running on Hugo or something like that. And then I tried to get a designer because I wanted them to redesign it, but they're like, well, we can't work with this because we don't understand anything about it. If it was a WordPress site, we could do something about it. So I migrated everything to WordPress. And I quite like WordPress too, because I can use the app to write blogs on the fly and I don't have to recompile it or do any of that stuff. I can just publish it to WordPress. So it was a very specific business-led decision to run my website on WordPress. So I said to Claude, I've got this WordPress website. It's using a standard template. I said to it, I don't understand the difference between themes, templates, and some other concept that WordPress has. Um, I know that the designers want me to pick a template, but then the template, can I change the template? I don't really understand. Like, tell me what I need to do to make it prettier. I was like really vague and like a typical business user. And so then it came back and it explained to me a little bit about how the WordPress things work. Because of course, WordPress is exactly the sort of thing we've been talking about. It's a legacy system which has had different things built on top of it. So it's got themes and it's got templates and it's got a bunch of different ideas, and they're not really.
I mean, it's a huge project built over decades at this point.
Exactly. If you designed it now, you wouldn't design it the way it's been created, right? So Claude explained a whole bunch of stuff like that to me. But then it also said, I think you should migrate your site to Hugo. And I was like, no, I literally just migrated from Hugo. Like, I don't want to go through the whole process and migrate it back. So it was a bit pushy, actually, because I don't know if it's because like it's aimed at developers and it just kind of assumed I was going to want sort of, or if it's got more experience with building Hugo websites or whatever. It was really strongly pushing me towards to migrating my entire WordPress site onto a Hugo site. I'm like, I literally just did this in the other direction 7 years ago. I'm not 7 years ago. Feels like a long time ago. I'm not doing it again. But it was quite pushy. So that was an interesting interaction because if I'd been less conscious in my technical decisions for my website to begin with, I might have been like, okay, then let's just migrate it to Hugo. You know best. And so it was really important to come into that, go, no, don't distract me. Like the idea is the website is there, the content is there. I know stuff is in the database, and I just want you to make it look the way that, well, I didn't even want it to rewrite everything. I was just like, tell me what I need to do. And so it goes, well, you don't need any of that stuff. We're just going to put like an empty, like a really plain, it's not a template, what's it called? Theme, a plain theme. And then I'm going to rewrite all of your PHP for you. And I was like, okay, good, because I don't want to write any PHP. So then it was just like giving me, we worked a little bit on what the design needed to look like. I had some ideas on what I wanted the look and feel to look like. I didn't want to do loads of, I have a friendly designer who I can work with if I want to, but I didn't want to do an overly designed website. I wanted something quite plain. I didn't want anything to be generating loads of images for me. I just want colors, like backgrounds, and I want to use my photographs. I want to use my existing content. I don't want to restructure anything. So you just kind of, you have to tell it all of those requirements, and you have to keep it on track all the time and say, no, don't like the purpose of this website is this, and this is the brand I'm trying to get across. And then finally it gave me a whole bunch of PHP code, which this is when it comes to the reading code thing. And I was looking at it going, I mean, I used to be a web developer years ago, but I did JSP and HTML, not PHP. I think I did PHP once. And I looked at it and I was like, if I really cared, I would code review this. I would look through it and I'd be like, well, that seems like a lot of code. Like in the style sheets, that it gave me a lot of styles in my style sheets. And I thought, I feel like there might be a better way of doing this, but I'm not going to go down that rabbit hole. It works. I'm just going to copy and paste it. I'm going to stick it in there. Oh, and Claude also walked me through having a local WordPress environment, which I hadn't had. The process with Claude was really great because a lot of my frustrations with WordPress are I don't know what I'm doing and I don't know how to get up to speed quickly. And Claude was like, install, it's called local WordPress or something, install the local thing, copy and paste these things, put this stuff here, set up this environment here. Now we can go. I'm like, oh, thank God. That was really easy.
Yeah, you can set up in minutes what used to take like hours or days just reading through
exactly
things.
And it really helped. And it was better than like a Stack Overflow thing, because you wouldn't get a Stack Overflow post which explains exactly what you need to do.
You have to piece them together, right?
Exactly.
How do you advocate, for the lack of a better word, a a good use of AI without so while maintaining your skills. There's a conversation in the programming community that uh, overly relying on AI can risk atrophying our hard-earned skills.
Yeah.
How do you think about that?
Yes. I think that's a really important balance to strike.
Any
I
tips on
have read.
how we would use AI and maintain our sanity and possibly even improve our skills rather than evaporate them?
I think, yeah, I don't have a quick win for this. However, I suppose I'm in quite a good position because as a developer advocate who has not been at the code face for like quite a long time, um, what I've learned for the last few years is that, again, we're talking about fundamentals. There's some things that just always stick with you, things that you know how to do. Um, So, for example, actually, today I logged into IntelliJ IDEA and I couldn't remember some of the keyboard shortcuts, and I was like, "Oh God, this is terrible! Like my brain is rotting away." Right. So, again, some of this stuff is just like repetition. So, some of the skills you really want to keep, like I really still want to be able to write JUnit tests, do some TDD, drive the generation of the code through the tests and do that. So I think for something like that, I would probably do some code katas every now and again, that helps me with the writing code, like dumb code. It also helps me with the keyboard shortcuts and navigating through the IDE and that kind of thing. So some of that stuff is just good for keeping the kind of muscle memory and the habits alive. And I think probably if I was working on a real code base, I think every now and again I would probably pick up a feature or a bug and be like, I'm going to try and do this by hand, or I'm going to try and maybe get Claude to point me in the right direction, but I'm going to code it, something like that.
So force
Um,
yourself to write code by hand just to maintain the muscle memory. Is that
yeah, maybe I might try that. Um, yeah, I think what's interesting, I don't know. I also think what might be interesting because we're talking about the writing side of stuff. Where the brain starts to rot is relying on AI to explain stuff to you all the time, right? Like I do this all the time. Like I tried to open a scientific paper yesterday and I got like 3 sentences into it. I'm like, I can't understand this. So I opened it in Adobe and said, summarize this for me, right? And it did a pretty good job of summarizing it, but it summarized it in really dry academic language. Then I said, can you summarize it as if I'm a senior developer who knows what they're talking about but can't cope with this language, right? And it did a good job and it put in examples and all the rest of it. But I feel like my brain is rotting because I just rely so much on the AI to like put stuff into a context that works for me. I think sometimes we just need to force ourselves to sit and read the code or force ourselves to sit and read the whole freaking blog post and not get someone to summarize it for us. And just exercise those muscles of taking the long way and slowing down a little bit because that's when you're going to reinforce the pathways in your brain.
what are some blogs? I mean, you've done some book recommendations. Even in this recording, you've mentioned quite a bunch of books in passing, and I know you've spoken about them in some of your conference talks as well. What are some blogs that are worth reading that are written by people who know what they're doing, avoid using AI for the writing part and for the thinking part, and offer genuine, useful information?
Um, I'm not going to completely meet your requirements. Kent Beck's Substack is excellent. He uses what he calls the genie a lot. And I think what's been really interesting reading Kent's stuff is that he's really having fun with AI, but he's also coming up with a lot of tips on what it's good at and what it's not good at. So Kent Beck's Substack is really good for that. Um, I've read a few articles by Charles Humble. He's written some stuff in AI for the rest of us and in lead dev, I think, talking about it's a bit more abstract about like, you know, about AI basically, and sort of some of the gotchas, and like also some of the sort of more societal impacts of it and that kind of thing. Um, what else? I gotta say, I have somewhat turned a corner, and I do tend to watch YouTube more than read blogs, which 3 years ago, I never would have been that sort of person. I would have been like, I'm a blog, I'm going to read stuff. Um, I am listening to audiobooks as well. So, like, I'm listening to Vibe Coding by Gene Kim. Oh, I read Steve Yeager's stuff about Welcome to Gastown, and some of his stuff is really interesting because he's doing loads of agentic stuff. He's like way out there, and it's interesting reading that, going, "Oh my God, is that like that? That doesn't. I'm not there yet. Like, what does that future look like?" Um, and then there's Dave Farley's Modern Software Engineering YouTube channel. So like he's got a bunch of people on that channel now, and they've all got their own views on software engineering generally, but also what works for AI and what doesn't.
Do you think, as an industry, we've figured out how to use AI properly? I think
God, no.
I mean, at least since agents came into our IDE. I mean, even with the GitHub Copilot, that was kind of like a blip in the IDE evolution with the things that you said you hated, and I'm pretty sure many other people replicate that experience. Ever since agents came about, we've kind of had a hard time figuring out how to do things, and pretty much everybody had to figure the things out for themselves. So everybody has their own process, which is far more different than having your preferred keyboard shortcuts in IntelliJ.
Mhm.
To what degree do you think we're getting close to something that sounds like a best practice?
Yeah, I've been thinking about this a lot as well because I keep talking about where we're on this journey and we're kind of on the cycle. We're definitely not there yet. I think we're still a little bit Wild Westy. And I think that's fine. I think that's where we need to be. I think we're trying out new tools, and not just in terms of like, because agents come with their own set of problems, right? So the thing I was reading yesterday was around uh, control planes for agents. So it's all well and good being a developer and you spin up three different agents and you look at their responses and you accept them or you don't. But like what happens, and this is where the Steve Yeager thing comes in, like what if you're running like 20 agents? And not to write code, but like 20 agents to review claim forms or parse inputs from whatever. I can't even, I'm having trouble imagining this world, which is why I'm reading about it at the moment. So once you start running loads of agents, then another thing I was reading yesterday was saying like you're in a management problem. So you, as the enterprise developer, because your agents are a large part of your enterprise software, they're doing things like, God, I don't know, deploying stuff or reviewing things, or and it's not necessarily about software engineering, but things like parsing inputs or talking to customers. You have these agents doing stuff in your organization, and you need to understand things like, do they have budgets, and do the agents report into other agents? Are there some agents which can make decisions based on a consortium of agents? And now you have like a totally different set of problems. And that you, as a developer who used to write lines of Java code, now you're worried about organizational hierarchies and budgets. And you're like, how did this happen? Right. So we're definitely not there yet. Agents just introduces yet another set of problems that we actually do have known ways of dealing with. We know how to structure organizations and set budgets and things like that. It's just that developers with computer science degrees don't know how to do that stuff. So we're still very much in this exploratory, investigative, scientific experiment space. I reckon, based on absolutely nothing whatsoever apart from the feeling from my own bottom, maybe, I don't know, maybe next year we might start to see some coalescing of, let's use the word best practices, or things that lots of people do that seem to work quite well, right? We might start to see some lumps of that happening next year. And then maybe in 28, maybe we start to see some things become standard enough to be boring, which would be a good thing. Um, Maybe. I feel a little bit like we've been through the panic stage, And I think we're maybe heading towards the right, how do we use this properly stage.
Is there a piece of tech in terms of programming itself, like a programming language or a library or a framework or tool that you find interesting at the moment and with potential?
Um, well, okay, so I've just got this
Is
new
that even
job.
relevant, by the way? I mean,
Yes,
that's baked into the question. Do we
yes,
care about
okay,
these anymore?
I like that. Yeah, okay. So I just got this new job and I am owning Aeron open source. I've been aware of Aeron for a while because I worked with Martin Thompson before he went off and created Aeron. I've seen a bunch of talks on it, and it's the logical descendant of the disruptor, which I blogged about years ago, which kind of started my career in DevRel. So kind of coming full circle, and I'm looking at Aeron, looking at Aeron properly for the first time. And so now I'm reading about message transport and idempotent stuff and like resilience. And what's really important is determinism and deterministic messages and about like reliability and stuff. So what's really interesting about this is because you might think, and there's no AI in it, of course, as well. It's just a Java, well, there's a C one, it's just a Java library that sends messages and has clustering and stuff on top. Um, and so it might be tempting to go like, well, I mean, that's not really very interesting, is it? It's just a Java open source library. And like, I don't need to worry about it too much because my AI will write code for that or either write my own thing. Please don't let AI write your own messaging framework. It seems like it's not going to get that right. Or, get it to tell me how to use Aeron. But what's really interesting about it is how is about determinism and deterministic systems, which is obviously the opposite of AI. But when I've been working with Aeron and reading the stuff about control planes for AI agents, the thing that's interesting to me is like how and where, how do we use deterministic systems? Where do we use deterministic systems? How can we use them to maybe mitigate the non-deterministic nature of agents and AI? And like we don't have to throw out the baby with the bathwater and go, well, AI is here, so like, we don't need to be deterministic anymore. We just accept the fact that the world is chaos and we don't really know what the answers are, right? And so I started to think about like how do we marry some of these good, solid, reliable, deterministic things with agents, agentic coding, or with our attitude towards AI? Um, yeah, so that's literally what's been going through my head for about 48 hours. That's where I am. And I know it was the weekend and I should have been paying attention to my children, but I wasn't. I was thinking about deterministic programming.
Anything in that space that you think has potential or other tools that caught your attention?
So I am also working with an AI firm at the moment. This is where this came from. They have a workflow control plane, which is about how to control agents. And what they're doing, which is why it reminded me of Aeron, their control plane is designed to be used from inside an enterprise Java system, and you call it like a normal API from with normal Java syntax, and you get a normal Java object back. But what it's doing is it's going off and running all these agents and managing them, and it's caring about their security, their protocols, and all the stuff that enterprise people care about, and all the stuff I was talking about in terms of like maybe roles and hierarchies and all of that crap is all kind of managed by the workflow control plane. And then you, as the Java developer, you just call another API and say something like, parse this claim form, right? And underneath the covers, the agents are doing it. But you, as a Java developer, don't have to worry about any of that stuff. And you just work with it like any other enterprise Java system. So I've been working with those guys for couple of months, just working with them like a couple of hours a week or whatever. And I'm still trying to get my head around it because they keep saying, what if you could work with agents as if it was just another enterprise Java system? And I'm like, but what does that look like? What do you mean? What are they doing? How does it feel? Like, is anyone else doing this? And as far as I can tell, no one else is doing this kind of thing yet, although there's a lot of very similar kinds of things around um, control systems for agents, yes. But the idea of being able to use very specialized agents from inside my enterprise Java application, I think that's really interesting, and I think it's something that I want to explore a bit more. And I'd love to see it in action and sort of see, like, how do we deal with the non-deterministic nature of talking to an agent, and do we care about it? How do we deal with errors? And does it change the way we program? Or if you've got the right kind of control plane, do I not need to care about it? Let's say that the agent fails to parse the claim form, the system just gives me back an exception. So I don't care, right? I just say parse this and it goes, no, sorry, I couldn't do it. So I find that really interesting.
Speaking of Java, within the span of your career, uh, it went through. I mean, through a period where it was pretty much frozen,
Yep.
and it went out of that to a 6 month cadence. How do you feel about that?
I really like it because it ties in really nicely with the message I learned at LMAX when we were doing continuous delivery, and has been reinforced since I've been at Gradle. Like the small feedback loops, the short feedback cycles are really, really important. So like if you have a 6 month release cadence, what was interesting about this is that the first release on the 6 monthly release cadence was Java 9 or 10? No, it was 10, Java 10. Java 9 was the last big one. And then Java 10. And, everyone was like, well, Java 10 is going to be a bit crap. There's not really anything in it. And even the folks at Oracle were like, well, there might even be some releases that just don't have anything in it at all because we just can't get anything done in time. But once they moved to the 6 monthly release cadence and they were like, these are the dates, this is the cutoff point. We don't wait for features, we just release on time all the time. I think in Java 23, there was 23 features, something like that. So they managed to, this fast feedback loop managed to allow them to deliver more than if they were doing these big releases. So I think that's really cool from a sort of feedback loop point of view. I think it's a really good example of why you release little and often. I mean, uh, often 6 months is quite a long amount of time compared to how some companies are releasing, but for Java, it's quite a lot. And I just really like the fact that what that's freed them up to do is it allows them to do, instead of working on big features like lambdas, they're working on big features like Loom, like concurrency, these kinds of things, Panama, all these different things. It forces them to break it down into small releasable chunks, which again is about fast feedback, and it's about something that's a good skill for working with agents as well. Okay, so we want to do a big thing. What's the smaller thing? How do we chop it down into the smallest possible things? And they can release bits of it that like people can't even use yet, let alone like it's not early access, but just refactor some of the JVM so that later on they can build something on top of it. But it kind of it's forced them to work in an iterative way, and it's really helped them to deliver a lot more features and in a way which is more interesting for us as consumers, because we were like, oh well, let's try this little feature here and let's try that, and then later on we'll get all of the concurrency changes, but for now we can start trying it and we can feed it back and say, oh, you know what, this is just not really working in these libraries, or it doesn't really work for my particular use case. And they've been really receptive to evolving the language according to the way it's being used, which I think has been great.
Over the span of this fast release cycle, I mean, even starting with the Java 8, um, Java has started uh, taking or borrowing features from other languages, most notably Scala and Kotlin, and
Mhm.
I'm the one to know about this. Um, how do you feel about the identity of the Java language? Has it lived up to its promise? Has it become, to a certain extent, unrecognizable from, I don't know, a while back?
Oh, I mean, I like it. I think that they've done a really good job of treading this incredibly difficult line between being backwards compatible, being enterprise ready, being reliable, being stable, being everything that banks can run their boring old software on, and being able to introduce new ideas and new syntax, being able to change the way concurrency works, introducing lambdas, it was a big change for us Java developers. We were like, what is this? Why would I inject behavior into this? That's a weird way of working, right? Every other language had had it for a million years. Um, so I like it. I think that they've got this balance right between having a look around at inspiration. Oh, so I was on a call, a webinar or something like that with was it John Rose or one of the other architects from Java, and I made a throwaway comment about them stealing stuff from Kotlin, and he was like, "We didn't steal it from Kotlin, we stole it from Smalltalk." So I'm like, "Okay, fine, whatever." Um, so I'm fine with them stealing stuff from different languages, especially because what I think they do quite well is taking a look at the things which work well, which will work nicely in Java, on things which everyone screams at them saying they want a particular feature, and then they're like, well, we're not really going to do that. We're certainly not going to do it in that way because it doesn't really work that well for Java. And there's lots of demands on them to do certain things. And I was just watching a talk from Martin Thompson the other day saying that Java is not really where it needs to be in terms of to be high performance. It needs to support certain things in the way it actually lays out data structures and things like that in memory so that it can be more predictable from a performance point of view. And that's kind of true, but it's also, it's a bit, you don't want to willy-nilly start ripping out data structures and changing the way that they're laid out in memory for a language like Java. So yeah, there's a long-winded way of saying I think they've done a really good job of like balancing those two things. I also think I often get asked as an ex-JetBrains person, like, how do you feel about Java stealing all the Kotlin features? And I'm like, well, I'm kind of fine with that too, because like Kotlin is free to do what it wants to do, and it's free to innovate, and it's free to move on. The same as Scala. And Scala, I feel Scala is quite different because Scala has its own niche, and I think it lives in that niche very well. It has its own developers, its own community, and it has its own mindset, you know. Kotlin was always kind of meant to be Java and Scala, but in a, like an easy to write, easy to reason about kind of way, which means that as Java catches up, then and as it has new concurrency things and stuff as well, some Kotlin users are going, well, you know, why do we need to be in Kotlin if Java's going to have all this stuff? But Kotlin can keep innovating and keep trying new stuff and keep putting new stuff out there. And that's the beauty of the JVMs. You've got the JVM, you've got Java, a nice solid workhorse of a language. You've got Scala, you've got Kotlin, you've got JRuby, you know, you've got all that, you've got Groovy. I still love Groovy despite all its flaws. And the fact is you can have all of those and they all play nicely together and they all live together in the same happy world. And we don't have to fight amongst ourselves. We can just like play nicely with each other.
To what degree do you think programming languages are relevant in the age of AI, especially the new ideas in programming languages? I mean, is there a temptation to think that we have kind of covered everything there is to know about a programming language, just use whatever's most popular, the TypeScripts and the Pythons and the Javas, and that's it, and just close everything else? And
No, I mean, yes, of course, there's a temptation to think that. Because I've just been reading.
versus new languages. So I spoke to the creator of the Flix programming language the other week, which is effect oriented and compiles on the JVM and borrows a bunch of things from Scala and from FX systems and whatnot. How do you think about this?
I love diversity. I think that we need all of this, right? Like we need new languages. What I like about new languages, I saw a presentation years ago when I first started going to conferences. I think it was by Damien Conway, and he said the language we use impacts the way we think. And he was talking about human languages. And I was like, oh, that's weird. And then now at that time, I mostly just spoke English. Now I speak Spanish and English because I've been in Spain for 13 years. I'm like, oh, it's true. Like you think about things a different way when words shape the way that you think about stuff. And programming languages are exactly the same, more so really, because of course you have object oriented and functional, and you know, and if you can have a language which supports things like, I don't know, event-based architectures and the language just kind of does it, then that's nice too, because what you want is you want the language to support the way that you reason about the applications that you're writing. Obviously with AI, the language you're writing in is English, but there's, you know, a lot of people making a really good point in that higher level languages have been a similar kind of level of abstraction for decades, right? And that's because they're just as precise as they need to be. They're like no more abstract than they need to be. Like you still need to be able to say if this, then that, right? Like programming languages are designed so that the computer knows exactly what you mean when you say the thing in the computer language. And human languages aren't like that. And the we still need the computer languages to talk to the computer. Is there a chance that maybe in the future, like us developers don't use higher level languages and we use LLMs? I mean, maybe. I don't know what that looks like. I probably won't be programming when that's the case. Um, I do think there's still a lot of value in investing time and effort into the programming languages, regardless of how many developers are going to be using them. Like Java, for example, I think Java is a great language for LLMs because there's so much open source stuff out there, so much documentation, so many cases. Just from a training material point of view, Java must be one of the best languages in the world. It must be. There's so much out there, probably Python as well. And I don't know, whatever GitHub's top 5 languages are. Um, but it also means that, the Oracle still needs to be investing in Java, the language, and adding new features and documenting them and getting people to use them and making it easier for the agents to identify what is the right concurrency paradigm to use and when you're going to implement one of these things. The danger of some of these things, and I saw this with Gradle, is that if there's a lot of stuff on the internet which does things the old way and not a lot of stuff on the internet which does stuff the new way, the agents get trained on all the old crap and not on the best practices ways of doing stuff. And I don't know if that's, I know the models are getting better, but I'm not really sure how they're supposed to be able to tell the difference between, you know, old ways of doing stuff versus new best practice.
Trisha, as I want to be respectful of your time, and I know we were closing on time. Um, for this audience, which comprises mostly experienced developers, I would say 10 years of experience at this point, is there a thought or a quip or a piece of advice that you would share with them before we wrap up?
My best piece of advice is don't panic. It's gonna be fine. I mean, maybe it's not, but the best that you can do is continue doing what you're doing. Like you're in this role for a reason, you're in this job for a reason. And if you can remember that, that's helpful. And if you can read things or watch things or listen to things which help remind you the things you enjoy or set you off in another direction that you're going to enjoy, then that's going to help a lot, especially during these turbulent times.
Nice. What a great way to close. Trisha, it's been a pleasure. Um, where can people find you? I'm going to leave links in the description.
I am on trishagee.com, newly redesigned by Claude. Yeah, you can find me on LinkedIn, Twitter, Blue Sky, Mastodon.
At
Yeah,
Trisha Gee.
and at Trisha Gee.
Nice. Trisha, it's been a pleasure. Thank you so much for making the time.
Thank you for having me.